Hi everyone. I wanted to kind of quickly go over the whole idea of directionality of the building of DNA and RNA. We know hopefully by now that things get built in the 5' to 3' direction, okay? But I don't think we've discussed why. And we just kind of said this is the way it is. So I want to go over why this is the case, okay? So if you look at this here, we have a phosphate, we have our sugar, and then off here would be the nitrogenous base. Then we have a phosphate, a sugar, and then our nitrogenous base. Okay, this works on any of the bases or whatever nucleotide you're talking about. So the bases are relevant right now. So that's why it's just says base to ease and clean up the image. So basically, where we get the termination 5' to 3' is from the sugar. In organic chemistry, when you are counting carbons, you are counting around from the oxygen. This would be the 1' carbon. This is the 2' carbon. This is the 3' carbon. This is the 4' carbon. And then this bend here is the 5' carbon. So DNA gets its direction terminology from which direction the sugars are pointing, essentially. The phosphate gets attached to the 5' carbon, and then the new nucleotide is going to form this link between the 5' carbon here with using a phosphate, connecting it to the 3' carbon. Okay, and then this bond right here that gets formed, this is called a phosphodiester bond, or sometimes you'll see it as a phosphor diester linkage. Okay, so you're basically linking the 3' carbon of this sugar molecule and the 5' carbon of this sugar molecule through a phosphate group. Okay, now this one is a new incoming when you have nucleotides out in the cytoplasm just whirling around. They have 1 to 3, or usually 2 to 3 phosphates on them. They don't have just the one phosphate group. So this one is coming in. Say this one's coming in to bind with this group here. What's going to happen is that those excess phosphates are going to be cleaved off. And by breaking bonds, we know that energy is released. And then that energy that is being released is going to be used to create this phosphodiester bond right here. Okay, so basically you release energy, those phosphates gets just go off on their own. Then this nucleotide can form a bond here with the 3' carbon oxygen bond here. Okay, and this is, notice this is the 5' end because it has the phosphate sticking out. This is the 3' end because it has that 3' OH group here sticking out. And so because this energy is released, it allows this bond to form. Okay, now if we were going to take this and try to put this up here, okay, you could try, but what do we notice about this where the energy comes from? It's only one phosphate. The energy's already been removed from it. So since there's only one phosphate group there, no more to cleave off for energy, you can't form the bond on this end. So you can't put a nucleotide going this direction. So that's why they're only formed in this direction, because the new incoming nucleotide has the energy and can attach to this 3' end of the carbon. So hopefully that gives you an idea of why the nucleotides only go in that direction. Know that this phosphodiester bond is a covalent bond, and it has to do with the number of carbons and the energy released, allowing it to form a new bond. And that's why all these new nucleotides are added in the 3' end of RNA and DNA. All right, let me know if you have any questions.